Hello, my name is Joshua Mugabi. I welcome you to States of Matter. A constant temperature, the product of pressure and volume of a given amount of a gas, is constant. This is Gay-Lussac law. Boyle's law. None of these. The answer is Boyle's law. According to Boyle's law, the product of volume and pressure of a given mass of a gas is constant at constant temperature. PV equals a constant. Rate of diffusion of a gas is directly proportional to its density. Directly proportional to its molecular mass. Directly proportional to the square of its molecular mass. Inversely proportional to the square root of its molecular mass. The answer is inversely proportional to the square root of its molecular mass. The rate of diffusion of a gas is inversely proportional to the square root of its molecular mass. Non-ideal gases approach ideal behavior under high temperature and high pressure. High temperature and low pressure. Low temperature and high pressure. Low temperature and low pressure. The answer is high temperature and low pressure. Non-ideal gases approach ideal behavior under high temperature and low pressure. At 25 degrees Celsius and 730 millimeters pressure, 380 ml of dry oxygen gas was collected. If the temperature is constant, what volume will oxygen occupy at 760 millimeter pressure? $365 ml, 449 ml, 569 ml, 621 ml, The answer is 365 mil. P1 equals to 730 millimeter. V1 equals to 380 mils. P2 is 760 millimeters. V2 is what we are looking for. At constant temperature, P1 V1 equals to P2 V2. V2 is equal to P1 V1 divided by P2, which is 760 times 380 divided by 760, which gives us 365 milliliters. The kinetic theory of gases predicts that total kinetic energy of a gas depends on pressure of the gas, temperature of the gas, volume of the gas. Pressure, temperature, and volume of the gas. The answer is temperature of the gas. The kinetic theory of gases predicts that total kinetic energy of gas depends on temperature of the gas. Gases deviate from ideal behavior because molecules are colorless, aspherical, attract each other, the answer is attract each other. Gases deviate from ideal behaviors because molecules attract each other. Dominance of strong repulsive forces among the molecules of the gas depends on Z and indicates that Z equals to 1. Depends on Z and indicates that Z is greater than 1. Depends on Z and indicates that Z is less than 1. Is independent of Z. The answer is depends on Z and indicates that Z is greater than 1. Because of strong repulsive forces, molecules of a gas cannot be compressed, and Z is greater than 1. The term which accounts for intermolecular forces in a van der Waals force equation is V minus B. RT to power minus 1. P plus A divided by V squared. RT. The answer is P plus A divided by V squared. P plus A divided by V squared represent the intermolecular forces in a van der Waals equation. The density of a gas A is twice that of gas B. Molecular mass of A is half the molecular mass of B. The ratio of partial pressure of A and B is one to 4, 1 over 4, 1 over 2, 4 over 1, 2 over 1. The answer is 4 over 1. PV is equal to nRT. P equals to WRT divided by MV, indicating that P is equal to DRT over M. PA over PB equals to DA times MB divided by DB times MA, giving us 4 over 1. A gas can be liquefied above its critical temperature. At its critical temperature. Below its critical temperature. At any temperature. The answer is below its critical temperature. Gas can be liquefied below its critical temperature. Hello, my friends. Thank you very much for participating in States of Matter. Please do like, share, and subscribe.